Okay, guys. Today the lab is going to be a half adder. So what we're going to do is we're going to use this particular circuit to add two binary inputs. We'll do a full adder another day, but today this looks somewhat simple, but it is not once you get into Tinkercad and once you put it into real life. So this is an exclusive OR. It's a 7486, and that is an AND gate. So an exclusive OR and an AND. So right here, we've got our first input, so our first binary, and that's going to be our second binary input, okay? So I would like you to try to complete this truth table. Um, what happens? I would like you to find the exclusive OR truth table um, and the AND table, just Google it and see what you can get here for answer there. How many inputs are there in a half adder? There's two. Um, and so here we've got the first digit and then the second digit, okay? Um, and there's two outputs. And what does each one? And so one is for carry and one is to add. And so let's get right in and look at the half adder circuit. So right here, the 7486 is the exclusive OR, and this is, let me zoom in, 7408 is the quad AND gate, okay? So let's go look at the 7486 data sheet here. All right, so inputs 1 and 2, and then output 3. And let's go to our 7408. I don't have it there. So let's go to Google, 7408 datasheet. All right. And so here we've got pins 1 and 2 and output 3. So let's go back. You're going to place your 7486. Make sure that power is going up here and ground is going in here. So I've got the power coming, so it's on this 5-volt rail. And then what I've done is, let's zoom out. And then I've got the 5 volts coming up here. So this is all 5 volts. This is ground, and this is tied to there, so it's all ground. For a circuit like this, you want to get organized, so you want to do that first. So then we're going to use input 1 and 2. We also have to have that tied if we go back to the lab. Where is it? Right here. So 6.5, we got to go, this is our wiring diagram right here. So these two inputs, they're wired directly to those inputs. So these gates, they've all got the same input. And let's see how we do that in practice. So we get the wire and we go from pin 1 to pin 1, pin 2 to pin 2, and then this is our 2 digits. All right. So right now I've got the simulation and we've got 1 and 1. So this would be the 1. This is the carry. So by carry, it means 1, binary 1 plus binary 1 is 2. So let's stop that. Let's look here. And I'm going to put this to 0. Okay. So now this is a 1 and that's a 0. Okay. And so we've got 1 plus 1 is 1. And so that's what this thing represents. Here's the 1. Let's stop the simulation. And I'm going to make this a 1 and this a 0. Start the simulation. Once again, 1 plus 0 is 1. Okay? So now I'm going to stop that simulation and I'm going to show you once again. Start simulation. Now we've got 1 plus 1 carry. So this is binary 2. This would be in the 2's column. Okay? It's reverse order as to the way we do it on the chalkboard. Let's do 0, 0 just to be thorough here. And I want you to do screenshots for each one of these. So let's go 0 and 0. Start simulation. And nothing lights up because 0 plus 0 is nothing. So this is a practical thing that we can use these circuits for. We're going to do a full adder later. And so what I want you to do is get the 7486, make sure it's grounded, 7408, make sure it's grounded, tie the two inputs together, and then we are going to tie the outputs. So right here, we can see that pin 3 comes off of here, goes through 220 ohm, anode, then the cathode goes to ground. Same thing here. We're going to go pin 3 out to this resistor, across, anode, cathode, up to ground, and we get all of that from this particular wiring diagram. All right, so I want you to always go back to this wiring diagram, make sure that it works. This is in industry the kind of drawing that you would get, and you would have to put something together. Um, this isn't overly practical, but it is a practical way to use these gates, and we're going to continue on this. And I put lab 6.5, so right there, and I will put a Dropbox in. All right.